Hello everyone. In this video, we'll be building a dice game dApp where players can deposit aelf tokens into the dApp smart contract, after which they can initiate a play process where the outcome is based on a verifiable random number that will be generated from AetherLink GRS, which is a decentralized Oracle network built on aelf blockchain. The difficulty level of this dApp would be intermediate. You should have some prerequisite knowledge of smart contracts, of how they are developed and how they are deployed on a network. Then you should have some prerequisite knowledge on VS Code, Node.js, .NET, and gRPC. So moving on, our first steps would be to setting up our development environment. So if you've been following our previous dApp tutorials, you might have already set up the development environments. Just to reiterate, I'll tell you the steps. So first we need to install VS Code on our system. You can follow through this link for installing VS Code. Next, we should install .NET 8.0 SDK. Just follow this link for installing .NET 8.0 SDK. Next, we need to install templates for aelf, which you can do through using this command. So basically, these contract templates are just boilerplate code for the ease of developing smart contracts on the aelf blockchain. Next, we have something called aelf deploy tool. So just copy paste this command on your terminal and you can install this aelf deploy tool on your local machine. Once you have installed this aelf deploy tool, just make sure that its path is present in your environment variables. Moving on to next step, we need to install Node.js and Yarn on our system. So just follow through these links for installing Node.js or Yarn on your system. Once we have done that, we can use Node Package Manager for installing aelf command. So by copy pasting this command into your terminal, you can install aelf command tool, which is a CLI tool for interacting with the aelf blockchain. And it enables us to create wallets and manage those wallets through our local terminal. So once we have followed through these steps, we can move on to our smart contract development. So first we'll go through the creation of the dice game directory and we'll create a boilerplate code for this. So just copy these three commands, go into your terminal. You can generate a sample folder like I did, or you can just simply copy paste the commands. As you can see, this will generate a sample boilerplate code for the dApp. So it will create a directory called dice game. It will move the current location to dice game and it will generate a dice master dApp boilerplate code. So as you can see, it has generated some protobuf files and the dicemaster.cs and dicemasterstate.cs file. Once we have done this, we can move on to our next step. Our next step would be to navigate to source directory. And then we need to rename this protobuf contract file to the dicemaster contract file. So just copy paste this command, go to the source directory, rename the contract file. So as you can see, now we have dicemaster contract.proto file. Earlier it was hello world contract.proto. Once we have renamed the file, we can implement the dicemaster contract proto file. So do a control V, or if you are in Mac, command A, command V. So once we have defined a proto function, so basically it contains all the method signatures which we have in a dice game. So if someone wants to interact with this dApp, they can use these method signatures for interacting with a dApp and making gRPC calls through it. So it contains all the different functions, like we have initialization function, play function, withdraws, deposit, which we'll discuss later on when we implement the dicemaster.cs file. So these are some functions inside this taskmaster contract.proto file. Once we have completed the step, we can move on to the next step, which will be the implementation of dicemaster state file. So just copy its implementation, go to the dicemaster state file, paste the given code from the tutorial. So basically this dicemaster state file, what it does is it contains all the state variables which will be used by a dApp, like Oracle node ID, subscription ID, player info, player records, owner. So these are some state variables that need to be maintained by this dApp. Next, we have token contract proto. So this file will be responsible for interacting with the aelf multi-token contract. Through this proto file, we can interact with the aelf blockchain token functions, like sending some aelf tokens to a different address, or approving the transaction, or managing different functions that we do through a wallet on a blockchain. So I'll just copy its implementation and paste it here in this protobuf reference folder. So once we have done this, we can see different method signatures present in this contract file, like transfer function, approve function, lock, unlock, burning the tokens, cross chain transfer. So we are done with this token contract step. Once we have implemented this, we can move on to the next step. Scrolling down a little bit. Yeah. So our next step would be to generate a Oracle contract file under protobuf reference folder. So again, we'll generate this file, copy its implementation. Yeah, so once we have copied this implementation, we can go through some of the method signatures. So basically, this proto file manages all the functions through which we can interact with the Oracle network, which is AetherLink on Rails blockchain. So it contains the functions like initialization, transferring admin, accepting admin, pause, unpause, creating subscription with consumer, canceling the subscription. So these are some functions that will be used by a dApp for interacting with the Oracle network. Once we have implemented this Oracle contract, we can move on to the next step. Next steps would be to generate a coordinator contract.proto file. So this will also be generated under protobuf reference folder. Here we generate a new file known as coordinator contract.proto. We copy its implementation, paste it here. So it also contains some functions for interacting with the Oracle. It contains some utility function like initialization, pause on pause, like we had for Oracle contracts. Similarly, this file will also be used for coordinating between the dApp and the Oracle network. So once we have done its implementation, next step would be to generate this Oracle common message proto file under references folder. We generate this Oracle common message. We copy its implementation. Yeah, so this proto file basically contains method signature for passing a request to the Oracle network. So it is just defining that structure, how that request should be made. Once we have done this, we can create another file named vrf coordinator contract.proto. We'll create this file. Under reference folder, once we have it, we'll copy its implementation. This is also just a coordinator contract for interacting with the AetherLink VRF, which will be used to generate our random numbers for the lottery for this dApp game. So once we have implemented this, we can move to our next step, which would be to generate this request interface under protobuf message folder. So we'll first uh, create this request interface.proto file. Yeah. So once we have created this, we'll paste its implementation. So this just acts as a intermediate files for creating the request for our Oracle network, which will be used via dApp. It contains some functions like start the Oracle request and how to handle the response from Oracle once the Oracle network generates the random number. Now, once we have implemented this request interface protocol, we need to create a new file called contract_references.cs. So I'll just create this new file under src, which is our parent folder. We'll create this file contract_references.cs. They'll copy its implementation. So it basically contains references to the different contracts, external contracts that we are interacting, like our else multi-token contract and the Oracle network contract. Once we have implemented this, we can move on to a next step of implementing the Dice Master games. Just copy paste the implementation of Dice Master game. Once we have pasted the implementation, you can see that first we set the Oracle contract address, which is the testnet dApp chain address for Oracle network on else. Then we define the token symbol, which will be used for playing, which is else tokens. We define minimum and maximum play amount. Then there is this initialization functions, which sets the token contract and Oracle contract. Then we have handle Oracle fulfillment. So this function will handle the response from the Oracle network and then decide if the player has won or not. If the player wins, then the smart contract or dApp smart contract will deposits winning amount to the player's address. And if he loses, then the amount will remain in the dApp smart contract. Similarly, we have play function, which performs some checks like if the input amount is within the limit, if the sender token are enough or not, if the contract has enough balance to start the play process or not. So yeah, these are some function. And once it performs all these checks, it will start the random number generation using VRF from the Oracle network. Then once we uh, have all this information, we can move on to our next steps, which can be like there is a withdraw function also provided in this dice game app, through which like any specified amount of tokens can be withdrawn from the contract if the player has deposited some amount into the dApp smart contract. Similarly, we have deposit functions also, which we can find later after scrolling down. There is a subscription ID and Oracle node ID set functions. So basically, this subscription ID and Oracle node ID is passed in the Oracle network request. So these are some prerequisites for interacting with the AetherLink Oracle network. So we'll add our dApp smart contract address as a consumer on the Oracle network, and once we do that, we'll have a subscription ID and Oracle node ID, which will be used for generating that random number. And as I told, we had a withdraw function. Similarly, we have a deposit function for depositing some aelf tokens from the player's account to the dApp smart contract account. Then we have function for transferring ownership from player. Then we have function for specifying the play amount limit, fetching the contract balance, getting who is owner, what is the subscription ID, what is the Oracle node ID, and so on. Then we can move on to our next step. Once we have implemented our dice master game, then we can move on to build this smart contract. So I'll just start the build process. It will take few seconds. So you can see that the build process has generated these two folders, bin and obj. And pay attention to this file, which is dicemaster.dll.patched, which will be generated here in this. Yeah, as you can see now, that dll.patched file has been generated. So just make sure that your build succeeds so that there are no errors and your dll.patched file is generated. Once this is done, we can move on to our next step. So our next step would be to deploying the smart contract. For deploying the smart contract, we need to have a wallet created. So for creating a wallet, if you have followed previous tutorials, you might have already done so. But if you haven't done so, we can do it in this next step. So first we need to uh, execute this command, else command create. This will create wallet on a local machine on a blockchain. It might take few seconds. Once we generate this local wallet, we'll save this info to a file. Then we'll export our wallet password. So the wallet creation process is still going on. We'll just wait few more seconds. Yeah. So now it is generated. We'll save this info to a file. We'll create the password for it. Just copy this address so that you can later on have a reference, or so that if even if the console is cleared, you have the address. Once we have the address, we can export our wallet password so that we don't have to enter again and again for security purposes. Once we have exported our wallet password, we need to deposit some tokens onto our wallet. So we'll go to the faucet for testnet. We'll enter our wallet address. We'll choose aelf token and we'll hit submit. So yeah, we have received the transaction has. So this means that the amount has been deposited into our wallet. Once this is done, uh, then we can start with the deployment process. So first, if you are in Linux and macOS, just execute this command. Or if you are on using Windows like me, you need to run this command. So we'll copy paste this command. Then we'll start the deployment process. So for deployment, we'll copy paste this command where our wallet address, and we have our wallet password, and we have contract path. Yeah, so like set up the contract path and wallet password, but we need to set up wallet address too. So like we earlier set up wallet passwords in the environment variable, similarly we'll be doing so for wallet address too. So I'll just copy paste my address here and replace the name with wallet address. Yeah. So now we can execute that elf deploy command. I'll just copy it and paste it here. Now we have our contract path set up into the environment variables, and we have our wallet password and the wallet address. So I'll just start the deployment. It might take few minutes, so we'll just wait for the deployment to complete. Please make sure that you have sufficient tokens into your wallet. If you don't have the necessary tokens to process this transaction, just go to the faucet for testnet and you can receive some testnet tokens from there. So we'll just wait for a few more seconds. Meanwhile, this contract is getting deployed on the testnet. Yeah, so our contract has been deployed, and here you can find the address for the deployment. We'll just copy our contract address for reference. So now we can move to the next steps, which would be, yeah, now we'll start interacting with our deployed smart contract. So if you want, you can also set up the newly deployed contract address into the environment variables. Oh, now moving on to next step. We'll start with the interaction with the smart contract. So first you need to approve the spending on your newly created wallet. For this, you can use this command. So this address is basically the testnet address for multi-token contract on Elf blockchain. And similarly, once you have approved the spending on your wallet address, you can similarly replace the wallet address with the smart contract that you just deployed here for approving the spending from the contract, as we'll be depositing and withdrawing through the dApp smart contract. So you will see some options once you have entered that command. Now command which initializes this dApp. So make sure that you use the wallet address which will act as a owner while you are playing the game for using the dApp. So when you are initializing, the wallet address which will be used will act as the owner wallet address for the gameplay. Next, we need to deposit some funds into the account. For that, you can use this command where there is this deposit function in the dApp smart contract through which you can deposit some tokens into the smart contract wallet. Once you are done with this, we need to set up some configuration before we can play the game on the smart contract. For that, we need to set up Oracle subscription ID and node ID for interacting with the Oracle network, which will need to generate the verifiable random number. So there is this add consumer function in the Oracle networks on testnet. So this is the address for that Oracle contract. You can simply execute this command on your VS Code terminal and you'll get the option to choose subscription ID and what will be the consumer for that subscription ID. So if you want a sample, you can use subscription ID 11, and for consumer, you can just enter the deployment address which you did for the dice game dApp. Like I have recently deployed this address. So similarly, you can enter that consumer when you get the prompt. Moving on to next step, we once we execute this subscription ID, we will have to set the Oracle node ID. So after executing this command, you'll get the prompt to enter the Oracle node ID. So for this walkthrough purposes, I will be using a sample ID which will be 4. Then we can execute this play function and sign the transaction using our wallet, which will initiate the play process. And meanwhile, once this is done, you can check the contract address by calling this get contract balance function. So next step would be to interacting with the deployed smart contracts using Frontend. Like for this tutorial purposes, we'll be interacting with our dApp through Frontend only. I'll not be using these commands to interact with the dApp right now, but you can do on your local machine. So for interacting with the front-end app, we'll first have to clone this repo. So I'll clone this repo inside Dice game tutorial folder. This repo has been cloned now. So we'll go to this directory. Okay. So yeah, currently the branch is master, but we'll change it to another branch. Oh, so currently you can check on the project website from where this repository has been cloned. We'll go to this website and check where our code is present. Yeah, so it is present in Dice game branch currently, but when you will be watching this tutorial, it might be possible it is present in master branch as the changes would have been merged by then. So we'll just go to Dice game branch. Yeah. So now we should be having a Dice game. Yeah. So now it is present. So we can migrate to the Dice game dApp directory. Now that we have reached inside Dice game directory, we'll install the necessary package to run the front end application. So we'll be doing a npm install. It might take few minutes. Oh, okay. So we are getting an error, unable to resolve dependency tree. So in this case, you can do a force npm install. Yeah, so now our packages would be installed. It might take few minutes, so we'll just wait for until this completes. Meanwhile, we can look into the other steps. So we'll need to go to the config test directory inside source config folder. Yeah. So here we need to put the address of our dice game that we deployed. For this tutorial's purposes, I have already configured a dice contract with the required configurations that we discussed. Like we have to set up subscription ID and node ID for interacting with the Oracle network. So I have already done that so that we can follow through this tutorial. Yeah. So we'll be using this sample deployed dice games address. Just paste it here. Moving on to next step, we need to update the smart contract address and then we need to set up wallet integration inside app dice account.tsx. So just copy this on connect to button click handler implementation. Go to app dice account.tsx. Here we can find the empty function. So we'll just paste its implementation. Moving on to next step. So this on connect button click handler basically represents when we click the play button. Then for disconnecting the wallet from our dApp, we'll be replacing this function. Next, we have wallet connect with RTK. So this will be used to connect to our portkey wallet. Now moving on to next step, we have use dice methods ts file inside app dice directory. So this method will be used to get allowance and set allowance and to combine them into a reusable hook for streamlined functionality. So we'll just copy the get allowance implementation and go to the use dice methods file. Here we can find this get allowance function. We'll test its implementation. Similarly, we have a set allowance function inside this use dice methods file only. So we'll paste its implementation. So this get allowance function basically retrieves the current token allowance for the dice game smart contract, and it ensures that the wallet is corrected before proceeding so that the user can play the game. Then we have to set up get player info and how to play the game function. Then we'll be implementing these functions to accommodate these functionalities. So we'll go to the use dice methods file and find the step G, which is get player info from dice contract. We'll copy its implementation. Yeah, here we can find step G, paste its implementation. Moving on to our next step, we have to fetch player information when the wallet is connected. So for that, we'll be implementing this use effect function. We'll scroll down here. We can find this use effect function. Paste the implementation for it. Then we have the main function for playing the game. Here we can find the boilerplate code for play function. We'll paste the implementation for it. Then once we have done these steps, so we have all the hooks required to manage the dice game methods in one place. So we have already implemented all the functions that will be required to play this game. So first we'll need to fetch player information. Then we need to spawn particle effects. Then we have to display the game results and handle the dice rolls. So moving on to our next step, we need to locate the file page.txs inside app dice directory. So we are already inside app dice directory. Here we have a file called page.tsx. We'll replace this use effect function, which will be used to fetch player information when the wallet is connected. So we'll scroll down. Yeah, here we can see that use effect function. We'll paste its implementation. Then we have to create a single particle effect, which you'll see in the later part of this video when we run the front end application. So we need to find this create particle function inside this file. Yeah, so here we can find that step K. We'll paste its implementation. Then we have step L, which would be to spawn multiple particle effects at a specified position. So we'll just copy its implementation, find the spawn particles function inside this page.tsx. Here we can see that step L. We'll paste the implementation for it, which will be to handle the game result. For that, we'll go to page.tsx. Here we have the boilerplate code. Now that we have implemented the handle game result function, we can move on to next step, which would be to roll the dice. So for rolling the dice, just copy this implementation, go to step in and paste the implementation for rolling the dice. So once we are done with this, yeah, now that we are ready to run the front end application. So we'll copy this npm run dev command, and meanwhile our packages has also been installed into the dApp. So we'll start with the npm run dev. We'll need to wait for a few minutes until this build gets completed. So until this build is getting completed, we can check through the next steps, which would be to set up the portkey wallet. So for setting up the portkey wallet, you'll have to follow this link and it will lead you to the extension for portkey wallet. Once you are done installing it, you can see this kind of screen, and you'll have to switch between the testnet or mainnet based on your application purposes. So for this tutorial, I'll be using testnet. So once you have changed the configuration to testnet, you can sign up using Gmail, or you can sign up through your Apple ID or with phone or email. So once you have successfully created your wallet, you'll see something like this. So make sure to deposit some tokens into the wallet so that you can sign transactions. For depositing some testnet tokens, you can follow through this faucet link and paste your dApp address, dApp wallet address on this platform. So here you'll get the option to paste your wallet address. Then you will choose aelf token and you can sign it. Then you can submit. Once you have done so, you'll receive some testnet tokens. You will be able to see the transaction hash for it in this green bar once you submit. Then our next step would be to connect our portkey wallet to the dice game. So we'll check if our implementation is ready or not. So yeah, our dice game is still getting compiled. It is currently running on port 3001. This is the default implementation for it. It might take a few seconds to few minutes in getting built. So we'll have to wait until it gets built. So now that it has compiled, we should be able to see the front end application in just few seconds. So it is compiling the slash dice path. Yeah, I think it has compiled. Just few more seconds. Okay, so we have received an error related to this dependency, which is at the rate port key contracts, due to which our compilation failed. So we'll have to install this port key contracts package. So we'll just copy this. We'll do a npm install port key contracts minus force. So this force flag disables the protections which our node package manager might be enforcing. So now that we have installed the port key contracts package, we'll again do the compilation for the dice game frontend app. We'll run the npm run dev. So again, it has started the compilation process. It might get stuck while compiling. So once you get this ready in 14.9 seconds after compiling slash instrumentation, just go through the localhost 3001 link so that the further compilation can be proceeded for slash dice pathway. Yeah, so it is still getting compiled. We'll have to wait few more minutes. So our front-end app has been deployed and we we can start the play process for this dice game dApp. So first we'll be clicking this login button and we'll be connecting our port key wallet. So it might ask you for your PIN. Yeah, so we have successfully connected our port key wallet to our dice game dApp. So now you can choose through these options. So I'll be choosing point one elf. So we have initiated the play method of our dApp. So I'll just sign this transaction. Okay, so once that function gets completed, you'll get a response like this. If you win or lose, as you can see, I have won 0.2 elf. So these 0.2 elf would have been deposited into my portkey wallet. We can verify it by going here. Yeah, as you can see, we have received this 0.2 elf in my portkey wallet. With this, I think this tutorial would be complete. So we were successfully able to play the dice game. We built its backend implementation, which was running through smart contracts on Elf network. Then we built the front end app for interacting with it. And with this tutorial is complete. So what we have learned so far, we learned how to set up the dev environment to build smart contracts and dApps on aelf blockchain. Then we built the logic for backend implementation, like how the dice rolls would be handled, how the rewards would be distributed into wallets, and how the bets will be managed. Then we successfully deployed the smart contract on the aelf network, and we interacted with the front end application to play the game. So for future developments, you can work on enhancing the gameplay for this app, like providing customizable bets to the players or having multiplayer options. Security of this dApp can be further improved through some testing techniques and following the best practices. Also, you can explore the cross-chain functionality so that this game is can be played with different players on other blockchains also. So congratulations. Have a good day. You have successfully completed this tutorial.